Now, as I told you, this is actually a functioning DB context, but for it to work inside our application, we're gonna have to jump through a few more hoops. So let's get on that and let me show you what is needed to make the DB context work. Now, first of all, inside our ASP.NET controller, we're going to want to be using the DB context, which means that we're going to have to let our dependency injection framework do its work and provide us with a DB context of the right type. So if I add one to my constructor as a constructor parameter, the dependency injection framework will actually send this to us. Now, if I use my movies context here, I'm going to store it into a private read-only variable so that all of my controller methods can use it for to do its work. And I'm only going to implement one controller method right now, which is the retrieve all. And I could just do a return OK, which is returning a 200 result, and everything I pass between the brackets gets serialized into the response's body, which is exactly what I want. So if I would just do context.movies, that would actually work. It would send back all of the movies. But you can still see that we still have this async, which is underlined in yellow. And that has a reason. This operation, once this hits the database, it will actually do a round trip. And that round trip is slow. It's something that can be awaited. So that's why this method was provided as sync, because we want to pause the thread while Entity Framework is doing its work and going over the wire to the database. So ideally, instead of doing this, we're going to want to do .toList async, which is the proper way to go to the database, and it will provide us with a generic list of all of the movies. So that is the better way of doing this. But then, of course, we will need to await this to get rid of the yellow line, and we will return a proper generic list of movies, and we are pausing the thread while we do so. Now, for this to fully function, I'll have to add my DB context to my DI container, and I'm going to do that in my program.cs file. As you see, we now have an extension method that is provided by Entity Framework, which is called addDBContext. And that takes a generic type parameter for the type of DB context that we want to register. In our case, that is movies context. Now, if we do this, we actually register the DB context in a scoped fashion, which means that for every subsequent request, we will create a new DB context, and all of the methods inside that request will get the same one. Now, as we will see in a later chapter in a web scenario, that is exactly what we want to see. So for now, I'm just going to leave it like this, and I'm not going to mess with it. To check whether this actually works correctly, let's go into the constructor of our movies controller and see if we're actually getting a movies context when we're trying to instantiate one of these controllers. So let's try it out and go into Swagger UI and actually call the getAll method to see what happens in our code. So I'm calling the getAll from the Swagger UI, and I'm checking what happens with our breakpoint. And indeed, our context here is a movies context. So that seems to be working correctly. Now, if I continue execution here, we will see that not all is fine. If I go back into my Swagger, I will see that there's an exception there, and the exception says that there's no database provider configured, which basically means that we haven't told Entity Framework which database engine it should be using, and we haven't told it which database it should connect to, and it suggests doing that in the DB context on configuring. So let's go there and do that. In order for us to do that, we will have to go back to our movies context and actually override the onConfiguring method. So we'll do just that. Now, the onConfiguring method is where the DB context instantiates and tries to figure out what it needs to do. So we can do onConfiguring and override that, and we can use the options builder to tell Entity Framework which database engine to use and what database to connect to. Now, because we're using the SQL Server package, we can actually use the use SQL Server extension method to pass in a connection string for the database that we set up in our Docker container. Now, this connection string has all of the parameters for it to need to work. You have localhost as its database server, the MoviesDB as its database, SA as the user, and we have that password that we set on the command line. So if we run this now, we expect to connect to this database and work. So let's try again and see how far we get. So we try again, we call the get all on this, and we get a new exception. And this time we're getting a different exception, and this is new for Entity Framework 7. So if you're using an older version, you might not get this, but it tells me that the same thing that my Azure Data Studio told me earlier. It is that the server certificate is not trusted. So it managed to establish a connection, but the certificate is invalid. Well, that's okay because we're in development, so we can fix this in the connection string. So let's go back here and add the part that we need to add. And it is trust server certificate equals true, which is the part that you need to add to your connection string. If we now rerun this, and we go back to our Swagger, and we actually try if this now works. We hopefully get through it, but we get a new exception. And this is the exception that tells me that we're getting really close. So we have managed to connect to the database and all the communication is set up correctly, but now it tells me that it cannot find the object named movies. Now, what is this talking about? Now, if I go back into the code, I can tell you which assumptions Entity Framework has used to look for a table named movies. Now, until we give it more information, Entity Framework is going to work by convention. So it's going to look for a table called movies because that is what the DB set is called on the object. And inside that table, it is going to look for these columns. And if it doesn't find it to work as such, it will throw this exception and stop work. So for this to work, we would have to bring the database into the shape that Entity Framework is expecting. But for us to do that, we would have to learn a lot more. And there's a quick way to do this, but it is a dirty hack. And I'm going to do that now so that we can iterate very quickly on the way that Entity Framework thinks, and I can show you way more things. Now, this is a dirty hack, and I don't recommend you doing this. So I'm going to put a comment here that will remind us to come back to fix this later. Now, the reason that I'm doing this is because by applying this hack, I can actually show you way quicker and with way shorter iterations what Entity Framework's reasoning is going to be when we apply changes to our model. So that's why I'm putting this in anyway, so that we can continue and learn more as we go. Now, because our DB context is registered in a scoped way, I'm going to need to create a scope first. So var scope equals, I can get the service provider from my app, and I can use that to do create scope. Now that gives me a proper scope as if I was making an HTTP request. Now from this, I'm going to get my DB context, and the DB context I'm going to get by using the scope.serviceprovider.getRequiredService, and I'm going to pass in the movies context type parameter. Now this will get a movies context from that scope as if I was using the DI container otherwise. Now I can use this context to achieve what I want, because I can use the DB context. The DB context has a database property, and the database property has two methods that will allow me to throw away all the tables that it knows about and to recreate them. So I can do ensure deleted, and I can do ensure created, which is the opposite, which will recreate all the tables for us. Now, when this happens, it actually throws away all the data, so all your data is lost. So that's why I'm saying you should never do this in a production system. But what this will allow us to do right now is check at what Entity Framework thinks the table should look like, and that's very powerful. So I'm just going to rerun this because this happens in the application startup. I don't have to actually trigger the method and hit a controller. I can go and look inside my Azure Data Studio and look at what the tables look like, and I get a movies table as expected. And that has the columns for all the fields that we expected as well. So I'm getting an ID property, a title, release date, and a synopsis, and I see that my ID is even the primary key for that table, which is what I wanted. So if I now go back to Swagger UI and I run that get all, what I'm seeing here is that we're getting an empty array. And because the database table is still empty, we are actually getting a correct response. And this means that I'm not getting any more exceptions and my database context is working as I want. So let's move on to the next lesson where we configure all of this a little bit more.